Hello everyone, welcome to my session on working with large Dataverse datasets in Power Automate and Logic Apps. During the last 12 to 18 months, I've been working in few Dynamics 365 and Power Platform projects that involved Power Automate and Logic Apps. Some of these implementations required processing large amounts of data. Although Power Automate and Logic Apps are good as low-code, no-code solutions, they have their own limitations, especially when connecting to Dataverse environments. Today, we will go through some of my learnings and experiences from those projects. Before we start, I would like to give a big thank you to our sponsors, ScriptRunner, DQ Global, Proximo 3, Redspire, Agilicis, and Hitachi Solutions. Without them, this event wouldn't have been possible. And if anyone wishes to share this event on social media, you can use the hashtag Scottish Summit 2021. Any support that you show would be greatly appreciated as well. A bit about myself. I'm Thanura Wijesiriwardena. I'm the practice lead for Dynamics 365 and Power Platform at HSD in Australia. I started my career as a .NET developer and made my way to Dynamics 365 and the Power Platform. My current focus is on Dynamics 365 and Azure Serverless Computing. My blog is evolved365.com and my handle on social media is ThanuraBW. We will go through four main topics today during the presentation. The first one will be querying the data. We will look into how to connect to a Dataverse environment and retrieve the data from that environment. And then we'll have a look at how to process the retrieved data, and then we will proceed on to check how to handle the issues and errors that we find while processing the data. And then finally, we will look at some scheduling tips for recurring jobs. First of all, let's have a look at the three main products and services that we will be discussing today during the presentation. The first one will be Microsoft Power Automate. Some of you may have used Microsoft Power Automate before. Some of you may have used Azure Logic Apps. It's good to know the differences and the similarities between these two products. Microsoft Power Automate, it is a process automation engine. It's within the Microsoft Power Platform. It's there to develop low-code, no-code automation solutions. It has inbuilt AI capabilities. The licensing is under Microsoft Power Platform or as a part of Dynamics 365, Office 365 licenses. And there's also per user and per flow basis licensing as well. Now, if you look at Azure Logic Apps, it's very similar to Power Automate. We usually call Azure Logic Apps the elder brother of Power Automate. It's a process automation and orchestration offering under Azure Integration Services. It's also there to develop low-code and no-code automation solutions. But a little bit different to Power Automate, this is mostly targeted at pro devs. And the licensing model is also different, where Logic Apps is linked to Azure subscription and it's per action billing. So you would only be paying for what you use. And it being a part of the Azure Integration Services, you get enhanced security controls compared to Microsoft Power Automate. One thing to note is you can export templates from Microsoft Power Automate and import it back into Azure Logic Apps, but you can't export templates from Logic Apps and import it into Microsoft Power Automate. The third and final product that we will discuss today is Microsoft Dataverse. Now, what is Microsoft Dataverse? It's a service to securely store and manage data that's used by business applications. You may also know it as the common data service. If you have worked with Dynamics 365 or Power Platform for a while now, you would know the common data service and how the data is stored in the backend. So Dataverse is the service that allows you to securely store and manage that data. It's a cloud-based storage option, and data from your Dynamics 365 application is also stored within the Dataverse. And you have inbuilt logic and validation controls, which helps you to quickly define rules and validation controls around your data. And you also have pre-built productivity tools, such as like you can edit the data from Excel, import it back. So you have different kinds of productivity tools that's pre-built by Microsoft as well. Now that we have gone through what Microsoft Power Automate, Logic Apps, and Dataverse is, let's have a look at how to connect to a Dataverse instance. There are two main connectors: Common Data Service Current Environment Connector and the Common Data Service Connector. The Dataverse term, the Common Data Service, was renamed to Dataverse very recently. However, the connectors are still called the Common Data Service connectors. The CDS Current Environment Connector, it is only available to Power Platform. So it's not available in Azure Logic Apps. The main reason behind this is Microsoft flows are hosted within Microsoft Power Platform, and Microsoft Power Platform instance has a direct connection to its Dataverse instance. So it has the ability to detect what the current environment is. On the other hand, Logic Apps are hosted externally in Azure Resource Groups, so it doesn't have that concept of a Power Platform or a Dataverse instance as a current environment. And cloud flows, which means the Power Automate flows. And if you use the current environment connector, will always connect to the Dataverse instance where it is hosted on. And Common Data Service Connector, on the other hand, that is available to both Power Automate and Logic Apps. It has the ability to connect to different Dataverse environments. So if you have a requirement saying you need to get data from another Dataverse environment or multiple Dataverse environments, then you will need to use the Common Data Service Connector. Both these connectors have triggers and actions, and some of these triggers and actions have the same name. Even though they have the same name, they have slight differences and in how we define them and how we can use them. And if you need to go into the detail, Microsoft documentation is a very, very good place to start. Let's have a look at how to query data from a Dataverse instance. Both CDS and the CDS current environment connectors, they have an action called list records. You can use this list records action to retrieve data from a Dataverse environment. There are some similarities and differences when you compare this action from CDS to CDS current environment connector. We will go through those similarities and the differences in the next slide. Both CDS and the CDS current environment connector supports OData querying and filtering. However, if you're using OData queries, there's a maximum limit of 100,000 records returned. So if your query is supposed to return more than 100,000 records, this action can only return up to the 100,000 records limit. This is a connector limitation at the moment. And if you want to use that 100,000 maximum limit, you still have to go and configure the pagination threshold property. You can set this setting by going into the list records actions settings area and by turning on the pagination property and setting a threshold between 0 and 100,000. If you have been working with Dynamics 365 and Power Platform, you might be familiar with another query language called FetchXML. Currently, only the CDS current environment connectors list records action supports FetchXML querying. The normal CDS connectors list records action, it doesn't support FetchXML querying at the moment. Similar to the OData queries maximum record count limit, FetchXML also has a maximum record count limit of 5,000. Compared to the 100,000 record limit in OData, this is a very low number of 5,000 records. You can get around this by converting FetchXML queries into OData queries. I use FetchXML Builder plugin in XRM Toolbox. It's an awesome plugin. You can use that to convert your FetchXML queries into OData queries. You can also build complex queries in this plugin. However, not all FetchXML queries can be converted into OData queries. If you are using filters on your linked entities or child entities or child relationships, that's when it gets harder to convert FetchXML queries into OData queries. If you can convert it, then you can extend your 5,000 record limit up to 100,000 records. Similar to the maximum record limit count in the previous slide, there are default limits of the list records action as well. If you're using the CDS current environments list records action, this value defaults to 5,000 records when pagination threshold is not set. So if you haven't set the pagination threshold specifically, then the maximum record count that you can expect is 5,000 records. And this is regardless of whether you use OData queries or FetchXML. If you're using the CDS connectors list records action, this default value is 512 records only. There is another important property called top count. In the list records action, you can see this parameter highlighted in the image. It's important that you know the difference between the pagination threshold and the top count property. It can be misleading as the top count property says the default value is all. Top count only applies to the subset of the records your query has returned. So it would not give you more records than the pagination threshold or the default limit set. If you are using, let's say in a query, you're expecting 100 records, and but out of that 100 records, let's say you order it by created on, and then you need the top 50 records, that's when you can use the top count field. Next important thing to remember is that the pagination works in 512 records per page. This means that the number of records returned may exceed the pagination threshold you have set by up to 511 records or more. Let me explain by using an example. Let's say you have set the pagination threshold to 60,000. Now, to get to 60,000, the system needs 118 pages worth of data. Now, 118 pages into 512 records per page is 60,416 records. If it had used 117 pages, that would go below the 60,000 threshold. So it needs 118 pages. So that's why you can expect up to 60,416 records when you run the query. Let's say you have a requirement where you need exactly 60,000 records or up to 60,000 records, then you would need to use both top count parameter and the pagination threshold. So if you set both of these configurations to 60,000, then you can expect only up to 60,000 records. And it is also important if you're using the top count parameter to set an order by clause, This way you know exactly how the subset of the records are taken from the full set of records that the query would have returned. Within the list records action, there are two more important properties that you would need to know. And the first one is the select query parameter. Select query parameter is used to limit the properties returned while retrieving the data. So if you're querying an entity or a table, you can define which fields you would like to retrieve in the select query parameter. And expand query is very similar, but it is to retrieve data of related entities. So for an example, let's say you're querying the contact entity and you need some data from the related parent account entity or account record. That's where you can define the field names of the related entities to retrieve the data. If you're using FetchXML, both of these parameters can be ignored, and there's a simple reason for that. It is because FetchXML has the ability to define the select parameters and also the related entities attribute as well as related entities queries or filters within the FetchXML itself. And because of that ability, you can ignore both of these parameters when you use the list records action. The CDS current environment connectors list records action, and this applies to Power Automate, has maximum buffer size configured or set by Microsoft. This is currently just below 105 million bytes. What this means is if you request data and if the data size that's returned exceeds the buffer size, you will get this error. And it's important that you try and limit the number of fields returned and try and reduce the byte count. Let's say you include large fields like multi-line fields that can go up to, let's say, 20,000 characters, and 20,000 characters into hundreds and thousands of records can play a big part or a big difference when you try and retrieve a large set of records. So try and limit the number of fields to a minimum, only to the required fields for your process. In logic caps, this limit is twice as of Microsoft Power Automate, and even though it's twice, it's really good practice to try and only use the fields that you actually require within your process. There is also a function that's supported by the CDS connector called aggregation transformation, and this is not available in the current environment connector. Aggregate functions, like its name suggests, that you can actually do the aggregation at the server level, which means you can ask from the list records action to kind of aggregate, let's say, give me the total sum of all the records, and it'll give you the returned result. But one main thing to kind of keep in mind is aggregate functions only supports up to 50,000 records only. So if you're using aggregate transformation and if it's more than 50,000 records, what you can do is you can retrieve the records and do the summation or the aggregation within your process. If not, you can just ask the list records action to do the aggregation for you. And when you are using the aggregation, and if you expect more than 50,000 records, and if it goes above 50,000 records, you can expect an error. And that the error is called the aggregate query record limit exceeded. And you would get this error if your query exceeds the 50,000 record threshold. And if you're using a filter, you can try and reduce the number of records returned. So aggregation can happen up to the 50,000 record limit. or you can use the top count limit as well. One of the most important best practices or a guideline that I use is I try and use an order by clause in all my list records actions that I use. The main reason is this ensures that we process the most important records first. In a scenario, let's say, where your job fails and it restarts, it needs the attention of the records that requires to be processed first. So if you define an order by clause, it ensures that we process the records that actually requires attention first. Because of that reason, I always try and use an order by clause, and I recommend everyone to use that. Let's move on to the next main area of the session, processing the data. Now that we know how to use the list records action, let's see how to process the data that's retrieved by the list records action. Once you retrieve the data from the list action records, you would need some sort of a looping control to go through the records and process them. There are multiple types of looping controls in Power Automate flows and logic caps. The most commonly used ones are the apply to each control in Power Automate, and the equivalent control in logic cap is called the for each loop. There are other loops like while and do while loops, but these two are the most commonly used ones and the ones I use as well. Both of these looping controls have concurrency functionality to improve the performance. Concurrency functionality will enable parallel runs of multiple threads, but if you're using variables within your loops, then you should try and avoid parallel runs. Now, what this means is if you are just using a variable as a reference or just as a read-only property, that's fine. But if you are setting a variable within your loop, then you should try and avoid it at all times. There's a reason behind that. It's because you can't um, define a variable within a loop. That functionality is not available in Power Automate or in Logic Apps. And because of that, if you use a variable and set it and reuse it within the loop control, and if you had set it to run parallelly, the same variable will get reference at the same time in parallel runs. And then that means you might not get the desired output required. And Microsoft has also recommended that you don't use variables within your parallel runs simply because of that reason. There are some defaults that you need to keep in mind. In Power Automate flows, if you're using the apply to each control, it defaults to process the records in a sequential manner. So if you don't set the concurrency controls, it will process records one by one. However, if you look at the same setting in Logic Apps, the default setting is to process multiple records at the same time or in parallel. It's important that you know this because there's a difference between Logic Apps control versus the Power Automate control. In Logic Apps, if you have a requirement to run your loop in a sequential manner, what you can do is you can set the concurrency control to on and set the degree of parallelism to 1, and that will ensure records gets processed one by one in a sequential order. This can also help in with the API limits, usage limits set by Microsoft. When you are requesting or consuming data through the Dataverse API, there are usage limits set by Microsoft. So if you increase the degree of parallelism to get better performance, However, you need to keep in mind the limits or the usage limit set by Microsoft, because if you exceed that limit, then your process might stop or get restricted. When you navigate to the Microsoft documentation page, there's limits for automated scheduled and instance flows. It's based on the performance profile set. So if you look at the performance profiles, they're categorized into low, medium, low 1, medium, low 2, medium, and high. And each of these profiles have certain plans or Dynamics 365 licensing attached to it. So based on your licensing or the subscription, you would have a profile, and based on those profiles, you would have action request limits. Now, these action request limits are dependent on different categories. So there are different settings as well. So runs per 5 minutes, runs per 24-hour limit, and concurrent outbound call limits. And based on your profile, the number or the restriction level will change. And all that is documented in the Microsoft documentation. And similarly, you also have API request limits. API request limits are also mentioned in Microsoft documentation, and these are based on the number of API calls that you can make within a 24-hour period. It varies from users compared to integration or service accounts or non-interactive users. And the number of API calls are defined based on the Dynamics 365 license or the Power Apps Power Automate license you have. Since we are talking about erroring out and getting restricted, let's move on to the next main section of the presentation, error handling. If you're coming from a development background, you would know what a try and catch block is. In development, we use try and catch blocks to execute some actions, and if something fails or an exception occurs, we catch it and handle the errors in a proper way. Similarly, in logic caps and in Power Automate, there's a control called scope, and you can use this scope control to group certain actions together and also use them as try and catch blocks. And what I usually do is I create two scope controls within the for each loops, and I call the first scope control as the try and the second control as the catch. How you handle errors is you can define the catch block to only run when the try scope control is failed or has timed out. That means the catch block will only trigger if the try block is failed or when it is timed out. So you can play with these controls. You can use scope controls for other functionality as well. And it's a good way to handle your errors. Once you have defined the try and catch blocks, you would also need to know what to do within the catch block. You have multiple options there. Let's say you don't want to process the rest of the records within that for each loop. Then you can decide to terminate the job there itself. You can use the terminate action to terminate the whole job. Or the other option is you can handle the error, for example, send an email and then continue on to process the rest of the records. If you are planning on sending an email, it's good to always catch all the errors. Maybe you can define a variable of an array type and keep appending to that, and then use all the errors at once and send one email to an internal user or an administrator at the end of the job. compared to sending multiple emails for each error that you find. But if your job is mostly targeted at customers, and if it's acceptable to send one email per customer within that block, then that's another option as well. You can also track your errors happen within your flows in the flow analytics. That's another good area. Microsoft have built lots of reporting around flow runs, which actions have failed, and it gives you lots and lots of information. So if you need to go back and have a look at what's happened in your flows, what errors were there, and which runs had those errors, you can go to that analytics tool. Dataverse or Power Platform has the ability to define your own custom actions. And these actions can be plugins or coded components as well. And you can register them as bound or unbound actions into your Dataverse environment. And you can also set these up to run synchronously. One good thing about registering them synchronously is if something fails within that transaction, it will automatically roll back everything. And within Power Automate, you have the ability to call bound and unbound actions. It's not available in Logic Apps. It's only available in Power Automate. So if you want to use that functionality to group certain actions together and call them in a transactional way, where if something fails, it can roll back everything done up to that point, use actions, bound or unbound, and then call those actions within your flow. Let's move on to the final section of the presentation, how to schedule and some tips around scheduling and working with large data sets. In Power Automate and Logic Apps, you have a trigger called recurrence. So a recurrence trigger is there to define scheduling of a job. So you can set it to run on every X minutes, X hours, X days, weeks, and months. And you can also set if you want to run it on certain days of the week or on certain times of the day. All those controls are there out of the box where you can configure. And for long running processes or long running jobs, there is a chance that your job may still be running by the time the next job is supposed to start. So you need to have a way of skipping the next run until the current run ends. So there's a control similar to the concurrency control in the for each loop. There's another control in the recurrence trigger as well. It's called the concurrency control as well. And you can set that degree of parallelism to 1, and that will ensure that your job follows a singleton pattern or approach. That means only one job will be executed at once. And the next tip I would give is based on a comment that I had on my blog post. There was an instance where someone had queried 4,000 records at once and also scheduled it to run at 2,000 records a run in 2 different jobs. It had taken the job less time to process 2,000 records twice compared to the 4,000 records at once. So sometimes it's good to have your data sets to a manageable size and in smaller batches over multiple runs and share the load over multiple runs compared to trying to process everything at once. And that concludes the main topics that we had planned for today. Thank you everyone for attending my session today. I hope you had learned something from my experiences. This video will be uploaded to YouTube in 14 days. And also share some love using the hashtag Scottish Summit 2021 in social media. Any questions, please feel free to direct it at me. My Twitter handle is at ThanuraBW, and you can also go to my blog post or the blog at evolved365.com. Thank you.